Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today we are going to talk about how you can partition data in S3 when loading it using AWS Glue job. So when you are creating an ETL job using AWS Glue and you're trying to load data into S3 bucket, how you can partition the data, we are going to talk about that. So let's get started. But let's first talk about why we need to partition the data. In a very simple term, you want to partition the data to improve data query or processing performance. So when you store your data into S3 bucket and you're trying to query data using, say, Athena query, or you are trying to process data through some other ETL operations, and if you want to improve performance of the processing, performance of the data query, then partition of the data is important. So if we ask a question that what are the ways of optimizing data query or processing query in S3 and what are the methods of such implementation, first way of optimizing such data query is by optimizing the amount of data scanned for the query. When you run a query on a S3 bucket based data, in order to give you a result back, you have to scan certain amount of data stored into S3 bucket. So the first lever of optimization is how you can optimize the amount of data that is scanned for the query. And there are two methods you can use to optimize the amount of data scanned. And the first method is doing a column level storage, or you can say column level partitioning. So you can use a column level storage partitioning method to optimize amount of data scanned. And the second is you can also do a row labeled partitioning of your data. And the second method which you can use to optimize is optimized IO operation. Now your data in your S3 bucket are stored into objects, or you can say individual files. When you try to access data from these files, actually you perform an IO operation, input-output operation on these files. And if you can optimize that input-output operation, you can optimize your data query performance. And the way to optimize your IO operation is by optimizing the file size. And we are going to talk about these three methods in greater detail in the coming slides. But basically, there are three methods you can use to optimize your data query performance, and they are all more or less partitioning of the data. So first your column level partitioning, then your row level partitioning, and the third is you can say your file size level partitioning. So these are the three partitioning methods you can use to improve the data query performance. Now one thing I want to make it very clear, these are not the only three methods. So there are some other optimization techniques as well, but I'm covering these three optimization techniques because they are related to partitioning, and I want to talk about how you can use AWS Glue ETL job to do such partitioning. So let's move forward. Let's take the first one. If I want to do a column level storage or column level partitioning to optimize the data query, to optimize the amount of data scanned for the query, what does it mean and how we can do it? So let's take example like this. Suppose this is a table where I have got ID, first name, last name, year, and country. This is a table which I want to store into S3 bucket. Now there are two ways I can store this data into S3 bucket. One way could be I can store this data using formats like CSV or JSON, which are row level storage, row level block storage. What exactly I mean by that? That this data, depending on how big the data is, they are stored into multiple blocks. But each of the block is keeping all the columns. So in this example over here, giving the sample table I talked about, assume that the data is stored into 3 blocks, block 1, 2, and 3. There's a typo here. There should be 3 here. And then you can see here that you have, 2 rows in block 1, 2 rows in block 2, 2 rows in block 3, but each of the blocks are keeping all the columns. Okay, that's the one way of storing where you're doing a row level storage, block by block. If we convert this into a column level block storage, which is like Parquet is example of that, then you don't store row by row, but you store column by column. So I can have, for instance, in this case, I can go up to 5 blocks. One block in this case is having all the ID column, other block is having the year column, then one block is keeping all the country column, and then 2 other blocks are keeping my first name and last name. Again, these ID could be stored in more than one block, but in this screen I'm trying to keep it simple. But you got the idea that you store your data when you go for column level block storage. Then you like in a Parquet kind of format. Then you store each data, each column per block. Okay, or your data data is stored column wise per block. Now, let's make a very simple query here. Say I want to select all the records for customer ID and customer year. So select customer ID, comma, customer year or year from this table, if that is the query I am going to run. In this kind of storage, you can see I have to scan all the blocks because my ID is spread across all the blocks. My year is spread across all the block. That means I have to scan all 3 blocks to get my ID. So you can think that I'm scanning the entire block set to get my 2 column select star. In this case, that's not the case because in this case, I just need to select 2 blocks, block 1 and block 2. I don't need to scan block 3, 4, or 5 because all my data is in these block 1 and block 2. These 3 blocks I can simply ignore. So you can see here the amount of data I'm scanning to get my 2 column select star is less in my column level block storage versus my row level block storage. So that's one mechanism you can use to optimize. Of course, if you're making a like select star kind of query, then you'll not get the performance. But if you're going to make any column specific query, then you can see that your row level block storage, you scan more amount of data for your query. For your column level block storage, you scan less amount of data for your query. Now, how do I do this column level storage? It's pretty straightforward configuration, and that's a good part in this whole tutorial is that all of these configurations are pretty straightforward. So when you're trying to write your data to the S3 bucket in your Glue job, and I'm using Glue Studio as an example here actually. Glue Studio's out-of-box transformations as an example, so that you have to not to think much, to be very honest, from the coding point of view. All you have to do is simply select the format. So if you, in this format, if you're selecting CSV or JSON as a format, then you're going for a row level block storage. But if you're going for Parquet kind of format, then you're going for column level block storage. And that way you can optimize your amount of data queries, data scanned for the query. Another optimization you can do, and that is you can also apply a compression type, because if you apply the compression type, then the data is stored in a compressed format. That further help you reduce amount of data scanned or size of data scanned to give you the query result back. So that's one way of optimizing your tree and how you can configure it in your Glue job. Let's move on to the other method. If I'm going for a row label partition, okay? So how I can do a row level partitioning. So first was like storage level partitioning, block storage level partitioning to be precise. Now we're talking about row level partitioning. Okay, exactly, table row level partitioning. How can I do that? Let's take an example here. Suppose this is a table I have. This is like a books table. In fact, this is I'm going to use in my demo in the later point of time. Suppose this is a table which which I want to store into S3 bucket. I have got my book ID, book name, publisher, author, publishing year, and publishing month. And since most of my queries are on publishing year and publishing month, I want to partition or do a row level partitioning for publishing year and publishing month. So just recall just what I said. I want to do row level partitioning on publishing year and publishing month because most of my query come for publishing year are filtered on publishing year and publishing month. This is very important if you're trying to do a row level partitioning. When you try to do a row level partitioning, you try to partition on those columns or those keys which are mostly used into your query. Since in this example, most of my filter criteria, filter conditions are based on publishing year and publishing month, I am going to partition my data on publish year and publish month. So keep this in mind. In a row level partition, you partition on those columns which are mostly used for your query to get an optimal performance out. Now, if I try to do a row level partitioning and first let's take example that I'm not doing any row level partitioning. So in this case, it's a no-brainer. In my S3 bucket, I get all my data stored like this kind of files, a flat file, like in a single bucket on a single folder. I get all my data put there. In fact, I'm using a Parquet as example here. So my format storage is Parquet, but there is no row level partitioning over here. So all my data gets dumped like this single files over here. And even if like and let's come to example later. So that's one method when I'm saying no row level partitioning. Now, so I simply dump all the files flat into one folder, job done. If I try to go for a row level partitioning, then I'll create a hierarchy of folder. So I have my top folder. Since I'm partitioning based on publish year and publish month, so under my bucket where I want to keep my data, I will create first layer of my folders, which is my years. That means first I'm going to split my data based on years. So here is my splitting of data, publish year 1, 2, 3, 4. So I'm splitting my data based on the year. Then under these folders, I further split my data based on month. So like for instance, if I go into publish year 1, if I go inside publish year 1, within that I have got my publish month 1, 10, 11, 12. I have got my data further partition. So further folders of my months. And then if I go inside a folder, like if I go to publish folder, publish month 1 folder, then I get my files. So that's the difference between no row level partitioning and row level partitioning. In no row level partitioning, under a single folder or bucket, I get all my data dumped then and there only. But if I'm going for a row level partitioning, like in this example where I'm partitioning based on publish year and publish month, then at the top layer, I get all my folders for my publish year. Under each of those publish years, I get my folders for publish month. Then under those months folder, then I get my individual files. So coming back to query. So suppose a query comes that, and just going by what I see on the screen, that, okay, give me a list of all the books which are published in publish year 2001 and publish month 10 or 1. Okay, publish month 1. Okay, just go by what we have our example here. So query is pretty simple. Give me a list of all books which were published in publish year 2001 and publish month 2001. Publish year 2001 and publish month 1 only. If in this file structure, I have to make that query. I have to open each of these files to get to know, to see for those records where published year is 2001 and published month is 1. Because looking at these files, I cannot tell you which file has published year 2001 and published month 1 data. So I have to open all the files to give you the result back. That means the amount of data scan is huge. I have to open all the files to get the job done. In this example, it's pretty straightforward. So you're saying publish year 2001. I can simply ignore all other folders because I'm looking for data for published year 2001 only. And then under published year 2001, I'm looking for month 1 only. So I can simply ignore other 3 folders and I can simply come to publish month 1. And under publish month 1, I have got only 2 files. I don't need to open other files. I can simply open these 2 files to give you result back. So amount of data I am scanning when I'm doing a row level partitioning is way less than what you do when you have no row level partitioning. So keep this example in mind, where how by simply going for a row level partitioning, you can reduce the amount of data scanned to minimum. Now, doing a row level partitioning is again pretty straightforward in AWS Glue job. When you are configuring a Glue job and you're writing to the S3 bucket, you can mention your partition key. Since you work with the catalog, and I recommend you to work with the catalog, because you know what, catalog makes your data discoverable and searchable and can also use this kind of benefits here. So when you are configuring your S3 bucket target writing, you can mention your partition key as a part of configuration. And when you do that, your data is automatically partitioned row level by your Glue job. And all this we are going to do in a hands-on lab. So of course you will see that as well. So that was row level partitioning. Coming to the third one, optimize the file size. Now, end of day, you are writing your data to the S3 bucket. So you're writing certain amount of data. Even if you do row level partitioning, you have to end of day write a file. Even if you're doing no partitioning, you are writing end of day you're writing a file. Now there are roughly 2 choices actually. I mean 2 extreme choices. One is that I'm using large files but less files, because if I'm using large files, then each of the files are keeping more and more data, and I need less file to store my data. Another option could be I'm keeping small files but more files, because of the small files I need more files to accommodate all my data. There are roughly 2 extreme choices, and both choices have their own challenges. So if I'm talking about the less files but large file size, then since it is less file, that means you have to open less files. That means your IO operation is less. But since the files are quite big, that means you have to, it's an expensive individual IO operation. Each IO operation will take a longer time because the file size is big, right? Other choice is more files but small file size. So since it is more files, that means you do more IO operation. More files, more IOs, more files you have to open. But since the files are small, you have your individual IO operations are less expensive. So because the files are small, so you have to read a small file. So your IO operation per file is small, but there are more IO operations. So you can see both of these have their own challenges. That's why there is a need that what could be that optimal file size, so that my number of IO operation and my individual IO operations both are optimized. Okay, so that's the quest you need to find, and that can help you optimize your file size partitioning to ensure that you are not doing an expensive IO operation, both number wise as well as the individual operation size. So how you do that? And that is the simplest answer. First of all, Glue automatically optimizes the file size for you. So I think there are some coding options available, which you can tell to say, okay, fine, don't make file size bigger than that. But to be very honest, what I have seen, Glue does that optimization for yourself. So probably you don't need to think much about that. The second thing, so Glue is doing it for you. However, there are options where you can actually cap the file size and those kind of things. And second, you must have heard that AWS has now come with a governed table. And this governed table actually, if you once enable this governed table, it does automatic file size optimization. So it has something called automatic compaction method, and using that, your files, small S3 objects are automatically compacted into a larger object to ensure that your I/O operations are optimized. So your I/O operations, you pretty much you can rely on governed table and out-of-box AWS Glue jobs judgment, because they can optimize file size for you, which can optimize your I/O operations across your across your files. These are the three methods, and again here you have to do least amount of work. Okay. In fact, any of the previous configurations were also not complex, but it was very important you understand why you want to partition in certain way and how it gives you better performance. So let's do a small demo. My demo is pretty straightforward. What I'm going to do is that I have an RDS table where I have kept my books thing, and then I'm going to write a Glue job. First, I will write the Glue job to store data with no partitioning at all. There will not be any partitioning, and not there will not be any row level partitioning, what I mean here. And then I'm going to change, and I'll show you the output of that file, and the file, and also how the schema is generated for such files. And then I'm going to change the Glue job, same Glue job, run again, but with data partitioning and writing to another S3 bucket. So we'll write two S3 buckets, and both will catalog separately, and we'll see how the partitioning versus non-partitioning look like, and how easy it is to change the configuration from one to another. So let's do this particular demo to see the whole talk in action. So here we are on AWS console. First, I want to show you that we have an RDS database. And if I go to my query editor to see how my data look like, it's pretty straightforward. It is one table, and then and that table has got I think 1,000+ rows, if I'm not wrong. Okay, so here is how my table look like. Oops, looks like there's typo here. No, it's okay. I should see my results soon. And I have provided the SQL of this table and also insert statement for this table. So you can use that SQL if you want to do this, like you want to run this data at your end for your own POC or practice purposes. So you can see here I have got my book ID, book name, publisher, author, my publish year and publish month. I've got some 1,000 rows here, and I want to partition based on my publish year and publish month actually. Okay, so this data and query table, create table SQL and insert, both I am providing as a resource in the through a link in description box below. So moving on, what I have done in my lake formation, I have created my database. So I have my database called DozoDB. In that I have created my table. And this table is actually cataloging this PostgreSQL table. So books table, it is simply cataloging. And if I open this one, it again looks pretty straightforward. It simply shows the table structure you saw in the RDS database. Okay. Moving on. So now my target location is S3 bucket. In that I have created two folders. One is books partition. That means I'll store here, when I write my ETL job, I will store here data with partitioning. And then I have books no partition, which I'm going to use to store data without partitioning. And of course, I'm going to catalog both of these data as well to see how the catalog looks like. So here is my no partition folder, which is empty at this point of time. Here is my partition folder, which is empty at this point of time. So this is the configuration I have at this point of time. And let's write a Glue job. So I go to my AWS Glue console, go to my Glue Studio, and I want to write a new Glue job. So let it open. Okay, here we go. So let's start the job. Configure the job in first. So go to the jobs menu. I want to create a visual with blank canvas. Create it. Okay. Now I want to read data from the source first. So I'm going to read data from my PostgreSQL database. Basically, it talks with my catalog. So in my DojoDB, my table is configured as Postgres public books as a catalog, and you can see it shows my schema and everything. So we are all good. We are all good. Let me in fact close this one so I get more space. You can see my table is cataloged. Now I'm simply going to write it to target. So I don't want to do any transformation. I simply want to dump this table data into target. So here's my S3 bucket location. Oops. Okay. Sometimes I see this challenge that I'm not able to configure it, and I don't know why, but let me see if I can make it work. But sometimes this happens. I cannot select. Here we go. So first thing first, I want to do a column level storage, so that I'm going to standardize in both of my jobs, partition or non-partitions. So Parquet. And then I want to convert into a snappy kind of compression. I can select many compressions, but snappy is considered the default compression method. And then I want to write to S3 buckets. First, I want to write this data as no partitioning. Okay, so no row level partitioning. So I simply browse here. I go to my I need to go second buff listing, Dojo Dataset, simply select no partition. So books, but no partition. And so I go to no partition here. I want to catalog my data, of course. I want to catalog my data. Once it goes to target and catalog into DojoDB, and then I simply say this is books, no partition. Yeah, books no part table. Okay, yeah, simple. Books no part table. I'm not adding any partition key here because I want to first show you how does it look like when I don't do any partitioning. So now I can go to my job details here, and here I can simply say this is Dojo Glue job. And I'm simply going to use one of my existing IAM roles to run the job. This IAM role I have created earlier, and then I'm simply selecting Glue version 3, Python, just default, everything default. Only thing I change here is number of retries to 0. Again, this I'm doing because I'm simply running it here, and if something fails, I want to know fast. In production, you want to keep number of retries to a number so that you ensure that your job does finish. So I saved this job configuration, and it was pretty straightforward. As you can see, that I'm simply reading data from PostgreSQL and writing to S3 bucket, and I'm simply cataloging it. It is in Parquet format, and I'm saying let's not do any kind of partitioning with this data, and I run it. So this will run my job. If I go to my runs, I can see my job running. So it's gonna take a couple of minutes before the job finishes. Let's wait for this job to finish, and then we'll see the outcome. And then after that, we are going to change the job to do partitioning, and we'll run again and see the outcome. So let's. Okay, so you can see the job has finished the execution. It has been successful. Let's see the output. So I go to my no partition folder first of all, and I refresh it, and you can see that my records are simply dumped over here, and you can see that data is auto. So there are some 1,000 rows, but they are partitioned across some 20 objects. So 20 objects are keeping my 1,000 rows over here, and this 2.3 KB of file size is automatically decided by Glue job. You don't need to do anything about it. You do not mention anything. It simply optimizes the file size for you here. Now, if I go to lake formation to see how my partition look like, if I go to my tables, I should see a new table called book no part table. And if I go here and see the output, I can see it is in the Parquet format, which is fine. And then you can see my schema, and there is no partitioning information whatsoever because there's no partitioning here. So good, this data is good, but this data is in a one way it is good that the file size is optimized. It is Parquet format, but it is not using the third lever of optimization, and that is using the row level partitioning. So what we are going to do, we go back to Glue Studio, go to my visualization again. I'm going to change this job. So I'll go to my this target location configuration. I keep this Parquet snappy. First change my location here. So I'll simply browse S3 and go to my Dozo data set, and then go and select use my partitions thing. So my partition thing, so I change my S3 location to partition in the same job. I still want to catalog in DozoDB, but this one I will call it, this is my book, book part table, books part table, but let's keep it book. If I make mistake first, I will repeat it again here. So book part table, just to keep the name consistent. So and then I add my partition key here. So click on add the partition key. My first partition key is my publish year, and the second partition key is my publish month. So here are the change to my job. No change in format and compression type. Change my location to books partition folder now. I still want to catalog it in DozoDB with name book part table, and then my partition keys are publishing year and publishing month. Let's save it. And once it saves, we are going to simply run it. So it is saved. I'm going to run it again. And if I go to my runs, I can see my job is running again. So this was my previous run, which has been successful. Now I'm running one more time. Let's wait for this job to finish, and then we can see the output and see how it has stored my data and also catalog my data. So let's okay, so you can see my job has succeeded again. So now I have got two successful job runs, one on no partition, then second one on partition. Let's see my output. So here is my partitions bucket. If I refresh it, I can see my partitioning done. So you can see here that I have got some 10 publish year folders, and if I go to a publish year folder, I can see multiple publish months here. And then if I go to a publish month folder, I can see my my individual files here. So you can see here my files are created, and so that's how it has been done. Now if I so you can see here now my partitioning is pretty straightforward. I have got my target like larger label bucket, then I've got my year first, then my month first, and under the month then my individual files come. Now if I go to lake formation to refresh my table again, I should see another table called books part table, and if I click on book part table, I can see my schema again. It's the same schema, only the addition is now it is recognizing my publish year and publish month as partition keys, partition key 1 and 2. So it is recognizing my partition, and it has also provided me my partition details over here towards the in the partition section. So with this schema, when you make a query and you are making query based on publish year and publish month, query will be automatically optimized, because based on this publish year and publish month, it can reach out to the right partition within your partition within your table, within your S3 bucket, to open only those files which keep your query data, not opening all the files. So that was the example how you can create your Glue job, and you can do a simple configuration changes when writing data to S3 bucket to do column level partitioning, to do row level partitioning, and of course Glue takes care of file size optimization by itself. And how these tricks and these methods you can use to optimize your query performance running on your S3 based data. So that was all for the tutorial today, guys. Hope you like it, and if you like, please click on the like button and please subscribe to my channel. I always look forward to your feedback in my YouTube channel, whether it is for a new content or you want to correct any of the mistakes I have made, or if you want to discuss any of the design architecture thing with me. I'm more than happy to have a correspondence with you to resolve your query, to help you in some way, and of course learn from there. So I always look forward to your feedback, your comments in my YouTube channel. It helps me improve further. So I promise to come back again in a week's time with another such video or tutorial. In the meantime, please stay safe and have a nice day. Bye bye.